we are going to talk about derivatives presented numerically. This section focuses on secant lines and the use of secant lines to approximate a function's derivative. A secant line through an interval is a line that intersects the endpoints of the interval, and as the endpoints gradually converge to a given point, the slope of the secant line can be used to estimate the value of a function's derivative at the value that they are converging to. And this is significant. Also, the slope of a secant line on an interval represents the function's average rate of change on the interval. So here I'm just going to show you the graph of a parabola, and I'm going to sketch a secant line, the secant line to the parabola on the interval here -3, or +3, excuse me, and here -1. And there is your secant line. So that is this is the secant line of the parabola on the interval -1 to 3. So the slope of this line represents the average rate of change of the function on that interval. Now, before we move on, we're quickly just going to discuss an application of secant lines, which is average velocity. This is used in physics very often, and basically the idea is that if you know an object's final displacement, how far it's gone, and the time it took, you can find the change in its displacement and divide by the change in time, and that will give you the object's average velocity on the interval, which is really its secant line, the secant line of its velocity function, its position function on the interval. And so another theorem that's important that deals with secant lines in calculus is known as the mean value theorem. And the mean value theorem essentially states that if a function is continuous on the closed interval a to b and differentiable on the open interval a to b, then there exists some c on that interval, such that the open interval, such that the slope of the tangent line at x equals c is equal to the slope of the secant line on the interval. In other words, f prime of c equals f of b minus f of a all over b minus a. If you are given an interval, and this value of c is on the interval a comma b. So, in other words, to solve a mean value theorem problem, one would be given an interval, and one would have to find the slope of the secant line on the interval, then differentiate the function that they are given, and set the derivative equal to the slope of the secant line. This will result in an equation that can then be solved for x, and the value of c would be the value of x on the interval a to b. And so overall, it is important to have knowledge of secant lines and average rates of change, because they can be used to approximate the value of a derivative at a given point. So that is some information about derivatives presented numerically.